Assalamualaikum, dear students. Welcome to all. Today I am going to discuss about standard nonlinear models. Okay, so there are models which can be linearized. Okay, those we can say they are standard nonlinear model. So this is linearization of nonlinear model or relationship. Okay, so we have exponential model is a nonlinear model, but we can linearize it. How? When we take ln log both side, this becomes this. So now your new y becomes this. So create new y, which is ln y, and then plot this y versus x. You get a linear line, and you can proceed as you proceed for a linear modeling. So get the A0 and A1 in the same way. Okay, same we have power model here. Okay, so if you take log both side, log y, okay, and log x. So this is basically new y for you. Okay, you can say this is capital Y and this is capital X. So if you get new y as log y and new x as log x, you can plot this y versus x, and that's become linear. Okay. Similarly, we have saturation growth model, which is in this form. Okay. And if you want to linearize this one, you have to just reverse it 1 over y. And this take this form. So 1 over y becomes new y, and 1 over x becomes new x. So you plot 1 over y versus 1 over x. Okay, and then this and then this is your intercept, and this is your slope. And I know this we have discussed earlier also. Also Dr. Anand discussed it well. So I will go to right away to the application, how to apply. So I will solve one of them in Excel and MATLAB. So I got this this problem here. Okay, you can see this one. This is about rate of production barrel per day. Okay, so for us and with time. So Q is basically Y, you can say, and T is basically X. So this is the data for Q versus time T. So if we have to fit this model and get the model coefficient B and A. So if you see here, this is more close to the model which we discussed here, and it's saturation growth model. So for that, what we need to do, we need to reverse this, and same is applicable to here. So 1 over Q will become 1 over B. If you reverse this one, 1 over Q will be 1 over B plus A over B. So we can go to Excel right away and enter the data. Okay, T and Q, T and Q, one 5 11 16 80. Okay, 258 185. One 10984. So this is T versus Q data we have. Now, if you plot this one, with the data, okay, you can see this doesn't look like a linear graph. Okay, just let me delete this part. So now you can see, yeah, this, if I fit a linear trend line here, let's see, equation and r square. Yeah, r square is not that good. So we, as question says, fit this model. Q equals b plus 1 over 80. So basically, if the model will be like this, 1 over q equals 1 over b plus a over b, and time will come here. This is all together and time. Okay, so what we have to do, we have to plot 1 over q versus, wait a second, one. Yes, so we have to plot 1 over q versus t. That will give you the linear. So okay, now let me get 1 over q, which will be 1 over this. So this is now new, this is, so this versus this should be linear. Okay, so if I change the plot, okay, let me edit this one and then use this in term of q, and t is the same. Yes, you can see this is linear, and if we fit a trend line, and we can get right away r square, and the coefficients, so slope is 0.006. So what is the slope? A over b, and the intercept is this, so 1 over b, which is equal to 0.0028. This is intercept. So what is the b? B will be 1 over this, and now a over b is the slope, and the value is 0.00306. So now b is already, we know, then a will be a over b is 0.006. so a will be b times, what is the b? B times this. So this is this is a, sorry, this is a. So this is the a coefficient, model coefficient a, and model coefficient b. So in this way you can linearize a standard non-linear model and fit the linear modulator. Once you linearize it, then you fit a model, and this is I have used right away the linear trend line. So this we can repeat the same exercise as we did. So this becomes like new y. This is basically y, and this is your x, and you can find the coefficient a0 and a1 by the sum of xy, that method, sum of xy and sum of the equation we have it for linear regression. For example, here, yes, so a1 and a0 you can find it here. So in this case, the model we are using, so your y is 1 over q, okay, and x is t normal. So this is the Excel part. Okay, how we can do in MATLAB?